Yeah, because the next lesson is kind of big. I think we might have enough time. It's not. It's all about now the graphs, velocity time graphs. Yeah, have you seen these before?
Yeah.
Yeah. So.
ST.
Yeah. Let's have a look anyway. So if we want to write this down, velocity time graphs now.
Velocity is direction.
Yeah, it's you could say speed time graphs if you want.
Speed time.
Yeah, because the only reason I say velocity is because for me it's okay if it goes under and it's negative, but speed is only positive.
Speed.
It's only positive.
Oh yeah.
Yeah, that's all. Okay, let's have a look. Right, so just some things before we start. In one dimension, so one dimension is a straight line, a positive number means you go to the right, and a negative number means you go to the left.
Yeah.
Okay. Vertically, a positive number means you go up,
Yeah.
and a negative number means you go down.
Yeah.
So one number could be a vector because the direction is if it's plus or minus. So, you know, for example, earlier I said like, you have like 2 meters per second east or 2 meters per second west. You can change that into just +2 or -2.
Yeah.
So the plus or the minus can be the direction.
Yeah.
Okay. So, for example, if s equals 1 meter, that means 1 meter to the right. And -1 means to the left. Now, just to be clear, this is not a rule. It's not a rule. You can say this is plus and this is minus, but most people say this is plus and this is minus.
Yeah.
Okay. So we call this a sign convention. It just means what we normally do. Sign convention. So maybe what you could do is just write sign, this word convention, and then you can just draw this. So this is normally plus, plus, minus, minus, just like in maths class. It's the same. So do you know this word? New word?
I know convenient.
Not the same, not the same. Different word. So can you write this down? Sign convention.
Okay.
Not sign convenient.
So the convention. What's the convention mean?
Convention means what is normal, but not a rule. You know what I mean?
Yeah. Just people always use the something.
Yeah, it's kind of like in Ireland you...
That's a hobby.
Well, I wouldn't say a hobby. Common practice.
Okay.
Common situation. You know? I give you an example. In Ireland, people don't wear their hat inside in the building. This is not a rule, it's just a convention. It's what people do,
Yeah.
you know. But it's not a rule, you know. It's not like you must take off your hat.
Yeah.
It's practice. Okay. Now, acceleration. This is a new word, I think. Did we do? Yeah, this is new. We haven't said this yet. Acceleration A is a vector.
Vector.
Is a vector.
Means
It has
it
direction.
has direction.
Yeah. So acceleration is the change of velocity per time. So as a formula, the acceleration is the change in the velocity divided by the time. That's what acceleration is. Where delta v is the change in velocity and delta t is the time.
Delta v means velocity.
The change. The change.
The change of
Yeah.
velocity.
Yeah. Yeah.
But I think velocity means speed
With direction.
with direction.
Yeah. So for example, I'll give you an example. So let's say the velocity is 3 meters per second northeast.
Yeah.
Okay? But then it changes to 4 meters per second northeast.
I know this.
You know this? So what's delta V? What would you say delta V is?
4 meter.
Mm-hmm.
4 meter per second.
Over?
No. How to say?
This is over. X over Y?
No.
No. Minus.
Minus.
Minus. Yeah.
Oh, minus.
Yeah.
3.
Yeah, correct. 4 minus 3, so that's 1
Yeah.
meter per second northeast. And let's say this took 10 seconds.
Yeah.
Over.
10 seconds.
Yeah. So that's 0.1 meters per second squared northeast. That's the acceleration. Yeah, you did this before? Yeah. So that's acceleration. That's the formula for it. Yeah, if you want to. Now, you should write, you don't need to write this down, I think it's okay. But you should write down this. Acceleration is the rate of change of velocity per time. And then this is the formula for it. It's okay? Right. Now, some letters. So, I and most people use the letter U to mean the velocity at the beginning. So here, this I would call U.
We always use V0.
Yeah, some places use V0.
And
Some
VT.
places use and VT.
VT is the
Last.
last.
Yeah.
Yeah.
We use U and V. In America, I think they use UI and UF.
Oh.
Yeah.
Okay.
So it's different.
Yeah.
Here we use U and V.
Yeah.
So
first class, I see that.
oh, you saw that? Oh yeah, in the first class. Yeah. U is the velocity at the beginning. This is also called the initial velocity.
Yeah.
V is the velocity at the end. This is called the final velocity. Okay.
So, initial means the first.
Yes, correct. Yeah. Beginning velocity. Yeah. You should write this down. And notice, this is called a convention because it's not a rule. In some countries, you use V0. You know, here we use U.
So, somebody can watch it at the same time?
The video? No, only when it's over can they watch it. So I don't think she's watching it now. Yeah. She might be watching the other video, the vectors. Yeah, the past one, yeah. Okay, what's the next letter? So I have U and V. What's the other letters? Maybe you know them. There's 3 more.
3.
U, V, what else? So we still have
Third.
A, the acceleration. How much the velocity has changed. The other one, of course, is T, and I think you know what T is. That's obviously for the time.
T. Oh, yeah.
And the last letter is S. And S is the displacement, the position. Yeah. So we use UVATS. What did you use in China? V1, VT?
V0.
Oh, V0?
VO, VT.
Yeah.
AT. S.
S, okay. In Ireland, in the past, it was UVFTS.
Pass.
Yeah, like many years ago, it was UVF.
Okay.
I don't know why F. You know, like I don't know why it was F. Okay. So here's an example. You know this person, Usain Bolt, fastest man. Let's think about his famous race. You know the where he won the gold medal. Like the world record, fastest person. This is the 100-meter race. Yeah. So what's the U? What's the U for this race?
U?
Yeah, U. What's U?
Me?
Oh no, the letter U. U.
Oh, U.
Yeah.
Oh,
Yeah.
0.
0. Because he starts at rest. What do you think the V is? Roughly. What do you think the V is?
10.
Yeah, maybe 10. Actually, I think it's a little bit more. I think it's more like maybe 12
Oh, 12.
meters per.
Because it just.
He starts at 0.
Yeah,
So.
and the last. I forgot is he finished the 100-meter, used the 10.
Less than 10. Like 9.6.
9.6.
Something like this, yeah. Yeah. So the V must be more than 10 meters per second.
Yeah.
The A, I don't know what the A is. Maybe the A is like 1, 2, I don't know, meters per second squared. The S we do know. The S is,
100.
it must be 100, yeah. Must be 100. And the T is like 9.6, something like this. Okay, so remember, velocity can be positive or negative.
Yeah.
Because it's a vector.
Yeah.
But speed is only positive.
Yeah.
Also, displacement can be positive or negative because it's position.
Yeah.
But distance can only be positive.
Okay.
Yeah. So just be careful with this. So what I'm saying is S can be between this and this, but distance must be bigger than this.
Yeah.
And velocity, like U and V can be this, but speed must be this. Okay, good, right. Now, don't be confused with this.
Yeah.
Now, usually this and this are the same. Usually, like in the example, the 100 meters, the distance and the displacement is both 100. Yeah.
Speed is.
And it's also velocity, yeah, positive, yeah. Good. Okay, now, here's an example of a velocity time graph. So, we can imagine somebody gets into a car. The car, well, first before I talk about this, here this axis is time, and this one here is velocity. Yeah? Now, you get into the car, and you 0 at the beginning, not moving. and then you accelerate slowly. This means you get faster and faster, but very slowly.
Yeah.
So maybe you're driving on a slow road. Then what happens here? What do you think happened in the car here? What do you think happened? You're driving your car on a slow road, and then what happens here? Yeah, you put your foot down, but why? Where's the car now? Maybe the car is on a highway, a motorway, a fast road. Do you know what I mean? What do you know what I mean? What do you call the very fast road? What do you call it?
Very fast road.
Yeah. Do you know the name for it? No? Okay. So, you know where the speed limit is 120 kilometers per hour?
Yeah.
That's called a motorway in Ireland. And in the US, they call it a highway. Yeah. Different countries have different names.
It's a road. Oh, I know.
You know, very fast road.
Yes. Yeah. High speed.
High speed road. Yeah. So maybe that's what happened here. He's going slowly.
Yeah.
And then he enters this road.
Yeah.
And he goes very fast. But then what's happening here?
Keep the speed.
Why?
Maybe he just achieved
the top speed.
Top
Yeah,
speed.
yeah, that's it. Now, probably what happened here, there's an accident. Traffic. Accident, yeah. So he has to slow down quickly.
Yeah.
And here he stopped.
Yeah.
Fix the problem, yeah. Something like this, yeah. This here now is negative, so that means the car is going backwards, reverse, and then at a constant speed. So maybe the road was blocked. So he stops and sees the block and then comes backwards. Something like this, we don't know. So can you see all these words? Accelerates slowly, accelerates quickly, steady speed. Whoops. Slows down. This is rapid deceleration. And this is acceleration. A and D. Because it's going down. Stopped. Speed up in opposite direction. And then steady speed in opposite direction. I need you to copy this with all the words, please.
Okay.
Yeah.
It looks like IELTS small.
Yeah, IELTS task 1, is it?
Writing.
Yeah. IELTS task. Is it IELTS writing task 1? Writing task 2?
Yeah. Task 1.
Task 1, yeah. Just like that.
I don't think it's slow down. It's very quick down.
I understand what you mean. In English, slow down means quickly or slowly. Yeah.
Also, it's crack.
It is. No, yeah, good question. Just for your English here, slow down just means go slower. This just it doesn't mean how quickly.
Yeah. Quickly, slow.
Yeah, so you would need to put an adjective here, like quickly slow down or slowly slow down. So that just means go slower.
Okay.
Yeah. Good question, though. It's good.
Speeding up.
Speeding up. Speeds up in opposite direction. Speeds up means go faster.
Do we need to cut down cut off some?
No, it's okay. It's okay. I don't think Gal will mind. Okay. Let's continue. So here's a little question. A car starts from rest. It slowly accelerates to 20 in 10 seconds. It keeps this speed for 5 seconds and then suddenly decelerate to rest in 4 seconds. My question is, just draw the graph. So let me see if you can draw it.
Rest.
Mm-hmm.
Rest means
Mm-hmm.
0.
Mm-hmm.
So the 20.
Mm-mm.
Oh, maybe here.
Mm-hmm.
20. And 10 seconds.
Mm-hmm.
And
Mm-hmm.
no.
Mm-hmm.
Like
Good.
15. And before
Suddenly, meaning after this.
Oh, after.
Yeah.
Okay. Suddenly. 4.
Yeah.
And 90.
Good. No problem. Yep. No problem. Good. Okay. Now, you maybe saw this triangle in middle school. It's called distance, speed, time. So if you want the distance, it's speed multiplied by time. If you want the time, it's distance over speed. And if you want the speed, it's distance over time. Have you seen this before? No.
Never.
No. Are you sure?
But I know how to calculate.
You know it, but you've never seen this triangle?
No.
I'm shocked. Distance, speed, time. So if you want the time,
Yeah.
then that's distance over speed. If you want the speed, distance over time. And if you want the distance, it's speed multiplied time.
It's very convenient.
Very convenient, and you've never seen it.
Yeah, never.
Amazing. Okay, maybe you should draw this. Maybe you should draw this triangle.
Yeah, it's very easy to remember.
Very easy. It's called the distance, speed, time triangle. Good. Okay, got that? Yeah. Right. Now, just so you know, this triangle only works if the acceleration is 0. You can only use this if there's no acceleration, if the speed is constant. Yeah. You knew this?
Yeah, I know this. It means A equal 0.
Yeah. It's just this on the time and the velocity.
Yeah.
Okay. So what do we do if the velocity changes? Well,
We have some what to say? Just
yes, the special formulas like these. Yeah, that's right. That's right. I don't think we need to do this question because I think you're all right with it. So we'll go on to this one. So what we're going to learn today is about the velocity time graph. So in fact, this graph, time, velocity, this here is u.
yeah.
This here, v. This here, t. Now, maybe you know this, but this area, this area represents something. Do you know what it represents?
Just if we know the how to say the
Yeah.
I know how to calculate.
Yeah. If you calculate this area,
Yeah, area. Yeah.
yeah, what do you get?
The letter.
Which letter?
All totally. Length.
S.
S.
Yeah.
Oh
Yeah,
S.
yeah. So why? Well,
Why?
look here. What's the unit here for velocity? That's meters per second. And what's the unit here? What's the units for this?
Time.
Yeah, so seconds.
Second.
So if this is meters per second and this is seconds, then the area is meters per second times seconds. So the unit here is meter.
Yeah.
So it must be S.
S.
Okay. Now, what does the slope represent? That's this divided by this. The slope, well, if you look here, that's the change in velocity
Yeah.
over time.
Time. Yeah.
And what's that? What's that called? Do you remember its name? It's the acceleration.
Ah, yeah.
Yeah?
Yeah.
So,
Acceleration.
yeah, acceleration. So, the u is the initial height, the height at the beginning.
Yeah.
The v is the final height. The a is the gradient, is the slope. You know, in maths, y2 minus y1 over, yes, x2 minus x1. T is the base,
Yeah.
that's the t. And s is the area, so that is the s then. So your velocity time graph can tell you uv ats, it can tell you everything. So can you write this down? You can write it or you can draw. What would you prefer?
curve.
Well, oh, yeah, curve is the graph.
Graph.
Yeah, so like you know, the curve. I'm sorry, it's okay. This is a line,
Yeah.
and this is a curve.
Curve.
But sometimes I use this word for both.
Oh.
You can use this word for both.
So I can say the U is
Initial height.
height.
Height at the beginning.
Initial.
Mm-hmm.
Initial height
Mhm.
of line.
Yeah, well, of curve.
Curve.
Yeah. Good. Right. Let's do an example. So, here, it goes from 0 up to 5, up to 10, up to 15, then 20, 20, 15, 10, 5, 5, 5, 5. Okay, can you draw this? So it starts at 0.
And
10. Okay.
and 5, 10. And the first
Mhm.
1, 2 times, first
15, yeah. And then 20, and 20 again. Yeah. And then,
15.
yeah, down to 15. Down to 10. Down to 5. And then 5 again. And 5 again. Okay, so I'll draw it 2. Time, velocity in meters per second, and time in second. Okay, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll have 5, 10, 15, 20. Okay, it starts at 0, yeah? And then what's next? 5, 10, 15, 20. Hang on a sec. So let me just draw these here to help. And then that's 20. Okay, and then what's next? 20 again. Okay.
And 15.
Okay.
And 10.
10.
5.
5. And then 5 and 5. Okay. So that's the graph. Right. Question 1. What's the distance? So the distance is the area.
Yeah.
So that's this. This.
I mean, I have a question.
Yeah.
If he just question the distance, but if it has a negative,
Make it positive.
so we just answer the negative, positive, the area.
Yeah, if it's negative, like this, you calculate this area,
Is this
this area, yeah, and add them.
Add them
Yeah,
also okay.
yeah. Not minus, add, yeah. Okay, so let's see, what's the area here? 1, 2, 3, 4. So a half 4 by 20. So is that 40? 40 meters? Yeah. This is 4.
Yeah.
Yeah. Okay, this piece here, that's 20. 20 meters. Okay, this piece here, 1, 2, 3, 15 meters. Actually, I can do the whole thing. I can say all of this. 1, 2, 3, 4, 5, 25. Okay, now this one is 1, 2, 3, 5, 10, 15, 22.5? Is that right? No.
Yeah,
No.
no.
Is it?
14, 5.
A half times 3 times 15.
Yeah.
Yeah, okay. Yeah. 22.5. I hope. Here, let's be lazy and use the calculator.
You're correct.
Yes, I am. Okay, so 40 plus 20 plus 25 plus 22.5. So the total distance is 107.5 meters. Okay, next part. What is the acceleration? So that's this piece here. So the acceleration is 20 over 4. Yeah, 20 over 4.
Oh, yeah.
20 over 4. So that's 5 meters per second squared. And now now time for this piece. Deceleration. 15 over 3. 5 meters per second squared. Now that's
it has
a minus.
minus.
Yeah, well that the deceleration doesn't, but here I could say the acceleration is minus 5.
Yeah.
You see this word deceleration?
Yeah.
This already means minus. Do you get what I'm saying? Like, I suppose if I say deceleration, that's equal to minus a,
Yeah.
which is equal to minus 5, which is 5. Because the a is minus 5.
Oh,
Deceleration.
Deceleration is 5.
Yes.
Means.
Yes. Means the acceleration is minus 5. Yeah. You can think about it like this: d equals minus a.
Yeah.
Okay. Okay. That's all. That's all for this question. That's okay. Yeah.
Oh, yeah.
Now we got time to do this one. Yeah, this will be our last one, and then we're finished. Okay. A mass can accelerate at 5 and decelerate at 6. The car accelerates from rest and then decelerates in 22 seconds. How far has the car travelled? So, and the car does not travel at a uniform speed. So what I mean is the car does this. It goes up and straight down.
Yeah.
Okay. So I want you to try this one. See if you can give me the distance.
Car travel meaning length.
Distance. How? The S. Yeah.
Yeah, distance is all of them.
The whole journey. Yeah.
Okay. Over rest.
Yeah, so it means here this is 22 and that's 0. Yeah.
So the
Interesting, yeah?
Just use A equals delta V per T.
Good, yeah.
And get delta V equals -22.
I'm not sure. Let me help you, yeah? So, watch this. What I'll do is I'll break it into two. And I'll call this T1 and T2. And I'll call this V.
Oh.
So you can say V over T1 equals 5.
Oh.
Also, V over T2 equals 6.
Okay.
Or if you want to be particular, you could say minus V over T2 equals minus 6. But it's the same thing. So, V equals 5T1 and V equals 6T2. So you can say 5T1 should equal 6T2. So 5T1 minus 6T2 equals 0. But T1 plus T2 should equal 22. So now you can find T1 and T2.
Oh. Just the math.
The maths, yep. So let's try and solve this. I'll multiply this by 6. So that's 5T1 minus 6T2 equals 0. 6T1 plus 6T2 equals 6 times 22, whatever that is, 132. So I get 11T1 equals 132. So I get T1 equals 12 seconds, and so T2 will equal 10 seconds. So that means V is 560, or also 6 times 10. It's the same answer. So in the triangle, this is 22, and this is 6. So the S would be 66. A half 22 by 6. So the answer is 66 meters. This is interesting. It's not so easy, huh?
Yeah.
It's a little hard.
Yeah.
It's a little hard.
Yeah, I can. You don't say it. I don't know the way.
Yeah, because it's difficult. It's difficult.
Example.
Good example, I think. It's a good example. Okay, so let me see. That's all. Let's see. Good. So, when's our next class? Do we have class tomorrow? Or Wednesday?
No. Tomorrow is math and
So
chemistry.
when's our next class? Wednesday? Thursday? Yeah. You have 2 homeworks.
Oh.
Wednesday, good. Okay, so I think, can you try to finish, where's it gone? Yeah, resolving vectors and the graphs, VelocityTime Graph.
No.
For Wednesday.
No.
Yeah, we'll see how you do. Okay, that's all. We'll finish there. Yeah.
Can I just
At this?
another example?
Oh, I closed it.
No problem.
But I put it on YouTube. You can pause and
yeah. I try.
yeah. So I'll put it up now.